All right, I'm going to go through another separable differential equation and solve this by separation. It's going to introduce a couple of new things as well as just being another good example. So, just like we did last time, we'll change this from f prime of x to dy dx equals 4xy. We'll use the Leibniz notation. And then we'll separate this. We'll get rid of the y over here, and we'll get rid of the dx over here. And what do we end up with? We get 1 over y dy equals 4x dx. Now, one thing you might have noticed is that what did I do? Well, I obviously multiplied both sides by dx, and I divided both sides by y. But I can only divide both sides by y on the assumption that y doesn't equal 0. But could y equal 0? What am I asking here? I'm saying, could y equals 0 be a solution to this differential equation? Well, let's look at y equals 0. It's just a horizontal line, obviously, going through the x-axis, along the x-axis. What is the derivative of y equals 0? Well, it's y prime. That's going to be just 0, right? It's the slope of that whole line is 0. It's a horizontal line. Well, does that fit with what I have here? Well, let's see. At any point along this function, y prime, yeah, at any point along that function, f prime of x, I put in any number, y is always going to be 0, so the slope, this function here, will always come out to be 0. So y equals 0 is a solution to this differential equation. So it is one solution. We're going to bracket it, hold it off to the side here, and bring it back in a minute. But right now, let's focus on this over here. 1 over y dy equals 4x dx. So we'll do the same thing we did before. Take the antiderivative of both sides. Okay. The antiderivative of 1 over y is ln, absolute value of y. And the antiderivative of 4x is 2x squared. And we'll have our plus c. Again, I explained in the last video why I just put the 1c. I don't have a c over on both sides of the equation. It doesn't matter. Okay. Now, I want to get y by itself, so I will do both sides of the equation, e to each side of the equation. I end up with e to the 2x squared plus c. Now remember, that just means e to the 2x squared times e to the c, or I'll probably write it like in this order, e to the c times e to the, e to the 2x squared. All right. And then get rid of the absolute value, so y will be plus or minus e to the c times 2, keep doing that, e to the 2x squared. Okay, so we have an equation. It says y is going to be some constant times e to the 2x squared. Positive or negative, some constant here. Now, so this constant here, what could it be? Well, it could be any positive number. It could be, could it be a negative number? No, right? Because there's no e to any power that's going to be a negative number. There's also there's no power such that e to that power is going to be 0. So this whole thing, this couldn't be 0, which means that the whole equation couldn't be 0. We know that it could be 0, right? Because we found that up here. We said, oh, well, y could be 0. So the way we have to write this, the way we fix this is to say, well, let's say y is going to be plus or minus some constant, c, or we call it c1. Do not confuse it with the c up here. E to the 2x squared, because that allows for c to be 0 or any positive number. Does it matter that it could the way we write it here, it could be a negative number? Not really, because we've got plus or minus there, so it's not going to make any difference. So this is going to be our final answer.